We're just going to look at some percentages work. This is at about a year 7 level, and hopefully just drilling down into the idea of how to find a percentage, and then also how to find, yeah, what percentage some number is of a whole or of some larger number. So let's jump into it. I'll put the link so that you can download this worksheet I've put together. Yeah, so you can work through it before, maybe watching the video, it might help. Okay, how many squares are in this grid? There's a nice, hopefully straightforward question. If you count these up, you'll see that there's 10 this way, and there is 10 this way. Okay, rather than counting them, hopefully we agree we can just do 10 multiplied by 10. It's a 10 by 10 grid, which must mean that there are 100 squares. Okay, shade in 25% of the grid. Okay, since there's 100 squares, and a percentage means out of 100, that just means we need to shade in 25 of these. 3, 4, or a quarter of the whole thing, right? So if I shade in a 5 by 5 part of this, then I would have shaded in 25% of the grid. So that's done in this blue color, let's say. So let's color code that. Using a different color, shading 17% of the grid. Okay, so let's do this in red. Well, again, it's out of 100. There's 100 squares, so 17%, we're just gonna have to shade in 17, right? Well, there's 10 of them. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there's 17%. So we've done that in red. Okay, now it's getting a little bit trickier. It says imagine that the grid has a value of 300. Okay, so for whatever this grid represents, yeah, maybe it's a chocolate bar worth $300. So how much is each square worth? Well, if we know that the overall value is 300, and we know there's 100 of them, if we take that $300 and share that evenly into the 100 pieces, so we divide it by 100, hopefully you would agree, we would get 3. So each square is worth 3. Each individual square is worth 3. Okay, and then we get this next part. It says, hence determine 25% of 300. Well, one way we can think about it is this 3 must correspond to 1%, right? Because we broke that grid up into 1% increments, and that one of them was equal to 3. So to get from 1% to 25%, we need to multiply by 25. So we're just going to take 25 multiplied by 3 gives us 75. Or we could write it like this. 25% per 100 multiplied by 300 equals 75. Okay, and you need a calculator to verify that, but I suppose this word hence here is hopefully directing you to use the information that you learnt about what 1% was. Okay, hence determine what 17% of 300 is. Okay, let's use this logic again. So we're going to do 17 multiplied by 3. That would give us 17%. Okay, and this is where you need to know your 17 times tables or your 3 times tables very well. So 17, what I would do is I'd do 20 times 3. Let me fully explain what I would do, because why not? 20 times 3 would give me 60, but I needed to multiply by 17, not by 20. So I've overshot 17 by 3 by going to 20. So I need to do subtract 3 times 3, which is 9. So 60 minus 9 equals 51. Anyway, that's just a mental strategy you can use to work out some of those more non-routine multiplication questions. Okay, let's have a look. So that was nice and easy because that was all out of 100. Let's do the next part, which is making it a little bit more challenging, but still hopefully getting you to think about how we can convert something to be out of 100, even if in this example, there aren't 100 squares. So let's have a think. This first question says, how many squares are in this grid? Well, 1, 2, 3, 4, 5, 6 that way, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 that way. So there's 6 this way, and then there is 10 this way. So there must be 6 times 10, so there must be 60 squares. And let me just erase that because we're going to need to shade in different amounts. Okay, and this is where I think it can get a little bit confusing, but it says shade in 35% of the grid. Well, let's sometimes when you're finding questions a bit challenging, it can be easy to say to yourself, well, what's an easier question to answer? If you were to ask to shade in 50% of the grid, you would know that that would correspond to half. Okay, so what if I said, all right, shade in 10% of the grid? Well, that's a little bit easier because we can see that along the bottom, it's broken up into 10 columns. So this must correspond to 1/10 of the grid. So this is 2/10 or 20% if I shade all of these in. If I keep going, this is now 30%. Okay, and then I need to get to 35%. So I need to shade in 3 more. So that's going to be 35% of the grid shaded in. Okay, another way to think about it, if you're really unsure and you prefer to use sort of formulas, to work out how many squares you need to shade, you do 35 over 100, so 35% multiplied by, well, there's 60 squares in total. And I guarantee you that will come up to be 21. And that's actually how many squares I've shaded in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So that checks out. Okay, now imagine that the grid has a value of 240. What is each square worth? Again, let's imagine this is a chocolate bar. It's got 60 squares. The grid has a value of 240. What is each square worth? Well, let's have a think. Each square must be worth, we take that 240 and we share it evenly into 60 squares. Okay, cancel the zeros. So we get 24 divided by, you get 24 divided by 6, which is 4. So each square is worth, each square is worth 4. Okay, so hence, what is 35% of 240? Well, again, we know that that 4 must correspond to that. Let's see. So we know that 35% of the grid is 21 squares, and we know that each square has a value of 4. So therefore, we can say that 35% of 240 is 21 multiplied by 4, which is 84. Okay, we can also verify this by doing a more standard calculation. You could say the following, you could say 35 on 100 multiplied by 240, right? Okay, and I guarantee if you put that in your calculator, you'll get 84. Okay, this might seem like overkill, but really what we're trying to do is we're trying to deepen our understanding of how percentages work. And so using a grid to visualize it can be useful. And it might be tempting to say, well, why don't I just always use the formula? But I would suggest that to get a really strong and deep understanding of this concept, you would need to understand why this logic works. Okay, let's try this last part. 48 is what percentage of 240? Show your reasoning by writing a mathematical expression. Okay. So now we have a question where it says 48 is what percentage of 240? So let's do the standard way here. So we're going to say that 48 is part of a larger whole. That larger whole is 240. Okay, and then what we're going to do is to convert it to a percentage, we're going to multiply by 100. So if you put that in your calculator, you will get 48 divided by 240 multiplied by 100 is 20%. Okay. Okay. But what I really want to do is to draw it back to this analogy that we have going. So let's think about 20% of the grid. So let's come back up here and let's shade in 20%. Let's shade in 20%. So 20%, da-da-do. That would represent 20%. And now we're still assuming that this bar has a total worth of 240. And we know that each part is each part here has a size of 4, right? Each one of these has a size of 4 if the entire bar is worth 240. So what we can say is 4 multiplied by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 4 times 12 gives us 48. So that sort of verifies the fact that 48 is 20% of 240. So again, yeah, it's important that we sort of make these connections between part and whole thinking when we're working through these percentage problems.